So, welcome to the Spatineo webinar. The topic of the day is simpler alternative encodings for INSPIRE data. And my name is Ilkka. I'm the head of customer experience and interoperability here at Spatineo, and also a member of the expert group for the INSPIRE alternative encodings. Just a few notes about the practicalities today. So headsets recommended for the audio. The presentation will last about 45 minutes today, and there is a time for questions and answers after that, at the end of the webinar. And we will monitor the chat information all the time, so you can find the chat window in your application, for the GoToMeeting application or the web page. So just let us know by the chat if you have any issues, technical issues, or if you have some notes that you want to make, some questions that you want to make immediately. I'm just already letting you know that the questions and answers session will also be done using the chat window mostly. So you can post your questions in the chat already during the presentation or after the presentation, or you can, after the questions and answers session starts, you can just post a question mark there also in the chat window if we want to express your question verbally. And the link to the webinar recording will be provided to all the participants by email after the webinar. So getting started with what are the most important issues for INSPIRE data access. The INSPIRE GML model is, for most cases, the GML application schemas in INSPIRE. The GML is complex, so it's deeply nested, and also the many of the GIS software, existing GIS software, actually would like to have a much simpler approach, simpler data structures, simpler data values in order to process them correctly. And the reason for this complexity is that the INSPIRE data models and the XML schemas, GML schemas have been pretty much derived from the UML conceptual models directly. So preserving all the complexity of the UML classes and the UML models. And as said, this kind of complex structure can be difficult for many of the existing GIS software, both open source and commercial, unless there is this bespoke INSPIRE adapter or pre-processing of the data. And this is obviously an issue because it would be nice to use as much of the existing clients and software to directly access the data and not have this kind of technical barrier for the data access. A kind of secondary issue here is that providing this complex GML data is also a bit more expensive for the data providers than simple GML, because you need more technical knowledge, more capabilities from the server software, also probably more computing resources and development time. So this is not so big issue because there are much less data providers than data users, but it's still it builds up to the cost of the INSPIRE implementation. And all this means that the actual data impact of INSPIRE is limited by the used technology solutions and the the data encodings and the models. Now, there are obviously two approaches to solve this problem. And in order to get really tangible results fast, we actually need to bridge the gap from both of these directions at the same time. So we need to make the data models and data encodings easier to ingest by the client software, and also at the same time improve the capabilities of the existing GIS software applications and software libraries in handling the complex data, and also making sure that whatever ways we create this kind of simplified data models encodings, we create something that is actually proven to be better ingested, more readable by the existing GIS software. So we need to check the whole process in order to streamline this data access. And this does not mean that the complex data exchange, the complex full-flavored inspired data models are to be replaced by something else completely, because there are still use cases for that kind of more detailed data that is provided by the full complex data structures that have been described in the current inspired data specifications and the schemas. But the idea is that in addition to what's already possible, what's already working in Inspire, we expand the possibilities, increase the impact of the Inspire data for the users that are not able to directly access Inspire data at the moment. And this is actually a small bit of history on what started this. Based on my understanding, is at least in the March 2017, there was an OGC technical meeting in Delft, and there was this session, Inspire What If session within that technical committee meeting. And many of the position papers submitted for this session actually mentioned the issue that something needs to be done with the complexity of the Inspire data models and structures. I'm sure there are already precursors to this in various forum discussion and Inspire thematic clusters and so on. But I think it really kind of picked up after this session. So it was clear that it would be nice to have some kind of strategy with the Inspire implementation for addressing this. And there are now actually two MIG actions that are related to this, like for the both sides of the same coin. One is about the alternative encodings. That's the 2017.2, and then 2017.3 is improved client support for Inspire data. So this is actually quite nicely, you can see the bridge gapping from what I just mentioned in the previous slides. It's actually being done in Inspire right now. Going a bit more detail to the first one of these groups, which is the alternative encodings. These are actually the mandated tasks for the group. So the idea is to develop concrete proposals for alternative data model encodings, define a template and procedure for proposing and endorsing additional encoding rules in the future, give recommendation also on the update of the Inspire documents about the encoding, data encoding guidelines. And the thing to note here is that changing the actual Inspire conceptual models, so the ones that you can find in the data specifications, are explicitly out of scope of this group. So it's only about taking the conceptual model data structure and seeing what can be done to simplify the encoding of that data. And this work actually kicked off in July, and the first example alternative encoding field that we are working in this group is GeoJSON encoding rule, and so that is probably the first thing that you can expect as a result from this group. And then we take what can be learned from that process, from how the GeoJSON encoding rule went, and apply to the guidelines for the following alternative encodings also. So it's a kind of pilot for creating this, and we're using GeoJSON as an example for an alternative encoding. Yeah, it made me a bit funny picture, but I think it's if you have a choice of defining a data model that's already keeping it simple, stupid, so a simple data model, and on the other hand, if you need to take something which is already complex and complicated and defined to be like that, and you need to make it simple and stupid, it can be quite challenging to do that. And at least the thing that you need is you need to have a very good list of the use cases that the simplification actually helps in making work. So you really need to, you can't support all the use cases out there, or in most cases you can't do that unless there are already kind of some kind of problems or over specification in the conceptual model. Usually this kind of simplification is not trivial, and you really need to be able to compromise on what's left in the simplified model, and how simple can you actually make it if it's not designed to be as simple in the first place. Now, there are different ways to address this question of simplifying data access, data models, and encodings. So obviously, you can start with the conceptual model, and then by automated means, semi-automated means, or manually create another UML level model, which is called implementation model. And at that level, you already kind of design the structure and the data types in a way that are simpler to encode in particular encodings. So this is actually quite nice approach in a way that you can use after this kind of simplified implementation model. You can use that as an input to several encodings actually, and apply the same kind of simplification rules already in between the conceptual model and the implementation model. There are some tools which actually can help you with this process. So you kind of define the transformation from the conceptual UML kind of model, UML described model, and say that what kind of simplification rules you want to create, use, and then you get another UML model which features this simplified structure. It is, as I already mentioned, this kind of simplification, then you need to support particular use cases, because you need to, in most cases, you need to make choices there on what kind of properties you actually leave there. If there are some voidable properties, should they be left out of the implementation model and just say, for example, that I don't have this property in the implementation model, which means that it's actually using some kind of default value, for example. So that means that you have less flexibility in some ways in the implementation model, because you can't express everything that's been in the more complex conceptual model. The other approach for this is you just try to make the encoding actually easier to read by client software, for example. And one way of doing that is kind of mechanically flattening the object hierarchy, using simple data values known already to be supported, so character strings, simple date times, and so on, numbers, and not having these deeply nested structures there. Then, of course, if you want to apply these, you need to verify that they actually make the data ingestion easier. This kind of moving this encoding into more machine readable way can sometimes make the data actually more difficult to understand by humans, because, for example, if you do flattened structures, you probably, in most cases, you end up with properties that are somehow linked in the conceptual model, but in the encoding, there are this kind of linking is no longer clear, because you don't know that these actually, when you change one of the properties, you should also probably change the other one, or the other one becomes irrelevant, for example. If you have a hierarchical model and you have both of these, all this information within this single block of data, then it's clear to a human reader that this is actually, these properties are related. So all in all, it is quite difficult to come up with one-size-fits-all solution for all the inspired themes in making things simple in this way. But yeah, we'll try our best, obviously, in this expert group to find out also these kind of generic rules, and also maybe go into particular data themes and particular data models and see what can be done to simplify those, keeping in mind that we have some kind of specific use cases in mind. And one example, which is you probably know if you deal a lot with inspired data, is that the geographical name thing is quite complex. And there is a reason for this, because then this is the full geographical name data model in Inspire. It really gives possibility to define in very fine detail a name of the place. So, for example, how the name should be pronunciated, whether that's like an official name of the place or something unofficial, and things like that. But if you have a use case where many of these actually are not relevant, and you end up, for example, in the data provisioning, in many examples and use cases that I've seen, data providers find it very difficult to populate these properties. So in many cases, they will leave them with the nil value, so unknown value, for example, or then they always use the same template for this data. So they kind of apply the default. They would like to just apply the default values, but the XML scheme actually mandates that some of these properties needs to be in the data, even though they would always have the same value. And this is an example of kind of extreme simplification, that if you really need in your use case only the information about the way the spelling of the name of the geographical name, and you can assume that it's always given, for example, in the Latin script, and that you don't have the source of the name information available, you don't have the pronunciation, or that's not relevant to the end users, and similarly to the nativeness and the status of the name is not relevant in your case. You just want to say that this is the name of a place called Helsinki in Finnish. And then you will end up with the very simple encoding for this, which only basically has a one XML element with one attribute, and that's it. So this is, as mentioned, this is an extreme example, and this has particular issue has not already been discussed in the expert group, but this is just an example of ways that you could use the simplification if you know that your use case this is fine, that this is always all the information that you need for these particular users is the actual spelling and the language of the name. And then you might wonder, how do we transform, if we need to transform this simplified model back into this complex thing, then it might help if in the simplification rule you have something called what I call implicit defaults. So there is this rule that if we have this simple way, it actually means the same thing as this kind of more complex encoding of the thing, but you just have to add these default values for the mandatory properties. So this could be a way to kind of nicely define the simplification that can actually go in, so you can actually go in both ways. But this is still kind of private thinking at the moment, so just to mention that this is not an agreed expert group position, just an example on how simplification could be done. Another use case, which is related to weather data and air quality data. There's this kind of simpler encodings for environmental data. It's been already demonstrated by at least the couple of customers that we have for the Finnish Meteorological Institute, for example. They have INSPIRE compliant WFS service, which actually provides weather data, air quality data, and many kinds of related information, environmental observation and forecast information. And how they seeing this is that if they would have simpler encodings rather than the complex observation and measurements based encodings for the weather information in their services, that would actually lower the adoption barrier for the developers using the data to build, especially to build mobile and web applications. But then the question, of course, is that if you just do a kind of proprietary simplification of the data, and then the application developers, they can't go and access the weather data from Sweden or Germany or France and expect the same kind of API, same kind of way to encode the data. So the standardization and harmonization benefits still exist there, and this is the issue that the FMI, the Finnish Meteorological Institute, together with a company called Vaisala, started thinking that we should actually find a better solution for this. And based on this problem statement, there are now currently 2 simplified draft encodings for observation and measurement-based data that are both based on the ISO standard, so ISO and the OGC standard for the observation and measurements abstract data model. One is using GML simple features profile, so a kind of restricted, more simple GML encoding, and the other one is a JSON encoding compliant with GeoJSON feature model, which is the RFC 7946. And the idea for both of these is that you have nearly flat structure, you have the property naming that still follows the OEM naming convention, and you kind of spice that up a bit with the latest W3C OGC work on the semantic sensor network ontology terminology. And this is actually, I mentioned that this is weather and air quality, but it's actually agnostic to the data themes, because this can be applied to any data that's based on the observation and measurements model. And this is actually, this is being discussed currently within the OGC on how to move forward with this, testing of this, and maybe even kind of standardizing this kind of encodings in the future. And also has been proposed as an example of a simplified encoding, alternative encoding for the INSPIRE alternative encodings group. Might be a bit small for you to see, but this I just wanted to show very quickly on how this actually looks like. So this is the GeoJSON encoding. So if you can, even if you don't understand GeoJSON, you can see that the property structure is pretty much flat. It's actually nearly flat, except for the features that are already within the GeoJSON specification, like the geometry, which can have these one level structure saying that this is actually a point and the coordinates are these. You know, all the other properties are just a flat structure within the properties property called properties in the GeoJSON. And similar thing with GML. Looks like this. So you don't have the deeply nested observation and measurements XML coding, the complex XML coding structure here that you might have seen. Instead, you have a hard typed observation type, which is in this case is called measure observation. You have the familiar properties like the phenomenon sign, result sign, procedure on how this measurement was actually made. What is the sampling feature? In this case, a specific weather observation station in Finland. You have the geometry, which is at the root level here, so it's easy to pick up by the GIS software. And this geometry is always the geometry of the ultimate feature of interest. So in this case, this neighborhood of Kumpula within the city of Helsinki in Finland. And the result is also given as a really simple value, 12.5 degrees Celsius is the temperature measurement in this case. So yeah, quite easy. This kind of structure is proven to be quite easily be readable with various existing GIS software already. So you can actually use either the GeoJSON or GML, and it's almost as easy to interpret. The simplification is not surprisingly, it's not a silver bullet. So it doesn't solve all the problems that you might have in the data access. It does make the data use easier in many cases because it allows to adopt the data exchange to less stable client software. And if you need to do the simplification process on a particular data model or conceptual model, you really need to, you're kind of forced to think on what is the really essential core bit of information in this for these particular users in this particular use case. So in that way, it actually forces you to think what should be preserved here and what is more important for the users. So in that way, it makes data use easier because the data users will get more relevant information to them. But of course, there is a potential downside also. The simplification can cause also more difficulties in some cases, because if you do a lot of these use case specific, user group specific encodings and simplified models, you end up with kind of a huge, or at least a few alternative encodings, which also might make it more difficult for the users to choose from which one should I use. And also, of course, if you need to support 10 encodings instead of one INSPIRE harmonized encodings, it's more work for the data providers. The simple data models encodings might not contain always the necessary information for all the use cases. That's clear. If you leave something out, if you restrict it in a way, for example, which is the case with the GeoJSON, that it doesn't support more than one coordinate reference system, and it actually doesn't support anything else than the CRS-84. And if it would be really useful and even necessary for your use case to use something else, then it could be a problem because you can't use that. You need to use another alternative, and you need to negotiate between the data users and data providers, and to see that for this case we need to use this one, for this case we need to use the other one. And as already mentioned before, a flattened data structure might make it difficult to kind of see immediately from the data that certain properties are actually related. Obviously, you can try to make that easier by naming, using some kind of naming conventions on the property names, for example. So you have the name of the feature of interest, and then you have the reference for the feature of interest. And if you use consistent naming on them, it makes it more easier for the human reader. But in many cases, the machines really can't say that this is probably related because it starts with the same string. So yeah, these kind of problems you can find if you do the simplification, especially if you don't really know what are the use cases that you're doing it for. And one quite interesting thing in here, which is not resolved yet, would be that how would you navigate between a simple and the complex data representation? So if you happen to have a simple data and see that this is interesting for me, but doesn't really contain all the data that I would need, would there be some way to kind of link that into a more comprehensive, with a complex presentation of the same data, and how should that be encoded, and how should that be presented to the user? I think that one of the questions that we need to think about in this expert group work. Don't panic if you have existing infrastructure. You've already got everything working in the INSPIRE compliant complex way. because these use cases are not going to go away. As I already mentioned before, these kind of simple alternative encodings and data formats, they extend the accessibility of the INSPIRE dataset to new audiences. So there are still many relevant use cases where the complex full INSPIRE GML data will remain useful. And you can find many of these use cases in the INSPIRE data specifications. And in some cases, you really need the original, close to the conceptual model complexity. And the one case is, for example, the coordinate reference system support. So if your data, if it's really important you have the data in your specific coordinate reference system, especially one of the European commonly agreed ones, the INSPIRE coordinate reference systems, default coordinate reference systems, and you don't want to transform that into Cirrus 84, then probably the GeoJSON encoding is not for you. So you need something else, and at least then you have the commonly agreed INSPIRE schemas already that can help you with this. Okay, now moving to towards the questions and answers session. There are some pointers here in the slides that you might want to go to follow and contribute this process. So the alternative encodings group wiki is behind the first link here. So you can find the relevant information there, then what is the scope of the group, as well as the minutes of the group meetings and so on. And also the improved client support group has this their own wiki that's not that active at the moment yet, but I'm sure will pick up once the group actually becomes more active. If you're interested in the examples that I provided for the simple feature encoded observation and measurements, there is a GitHub repository under the Open Geospatial Consortium GitHub organization that has these kind of drafts for the GML and the GeoJSON OEM encodings. And obviously in our company's blog and the webinars page, you can find more information on this as this work progresses and we get some tangible results. So right now I would like to give you the floor in a way to, if you have any questions or any comments on the presentation today, please feel free to use the chat window to send a question, or if you just want to use your mic, then fine. Okay, we have a question from Roel Huberts. And the question, yeah, you can see the question right. So if I understand correctly, the simplified alternative encodings enable easier client access to complex INSPIRE data for users, but do not make it easier for the data providers to harmonize existing data sets into INSPIRE complex conceptual models. Since simplification starts from the original complex conceptual models, the data needs to be in this form first to be able to be simplified into alternative encodings. This is, as far as I understand, this is correct. So the starting point are the current conceptual model. So it doesn't mean that the data needs to be within your database or structure. It needs to be following that model, obviously, but it means that when you start from your database or your file system where you have the original data, you kind of identify the things that are within the conceptual model, and then using these simplification rules, you can find out that where and how do you need to maybe transform those bits of data in order to fit them in this simplified encoding. So it doesn't mean that you have to do the round trip from first making the complex encoding and then simplifying that. But of course, the starting point is that you can find in the conceptual model within your placed in the simplified encoding. Does that answer your question? Okay, if there are no other questions, I would like to thank you all for joining the webinar today, and I hope this content has been useful to you. If you have any questions later on, please don't be shy to send me an email, and we will send you the link to the webinar recording after this. So if you want to share the contents, the recording with your colleagues, for example. Yeah, there's another question from Ro. Do you have any information about an RDF and alternative encoding? Yes, there is actually a document that has this kind of RDF encoding as an alternative. I think that was already it was published already before the group started working. It was actually one of the reference material in the group's work. So as far as I understand, that's actually that's kind of a bit out of scope here, because the intention of that was not strictly the simplification or the alternative encoding, but I might be wrong. That's a good point. Maybe we can check whether we can use some of the components from that document already within the expert group work. Yeah, but it certainly was within the scope of the original group work, because it was one of the kind of additional background resources for the members. Okay, so as said, thanks to you all, and we will in contact in sending the link to the recording, so you can share that with the people who maybe couldn't make it here today in person. So thank you again for joining, and have a nice rest of the day, and welcome to our webinars again next time.